Ladies and gentlemen, hello again. Welcome to another Reflected Reality Simulations video. My name is Graham, and this is an extra video in the Hotstart TBM 900 series. Extra videos are just a few minutes away from the simulator, where we can look at some of the concepts from the flying videos in a bit more detail. Now this follows on from part 3 of the series, where we did an IFR flight from Aberdeen to Dundee in Scotland. We finished up that video flying a circle to land approach on runway 27 at Dundee. For a simulator pilot, circling to land adds a little bit of interest to the final stages of the flight. In the real world, it's a challenging, complicated procedure that carries a lot of additional threat beyond a straight-in approach. And it's one of the places in aviation where the procedure design rules are of more importance to the pilot than you may first expect. So, in this video, we're looking at approach minima and circling. As with most things in aviation, the rules depend on which part of the world you're in. In this case, there's two systems we're interested in. We've got TERPs and PANSOPs. TERPs is Terminal Instrument Procedures, PANSOPs, Procedures for Air Navigation Services, Aircraft Operations. TERPs is largely an FAA thing, although other countries, such as Canada, use TERPs rules. The rest of the world mostly uses ICAO's PANSOPs. Now, TERPs and PANSOPs are essentially rulebooks for instrument procedures. It is the methodology in how an instrument procedure is created. An instrument departure, an instrument arrival, they'll all be constructed in accordance with either TERPs or PANSOPs. To make it simple for pilots, aircraft are categorized in one of 5 categories, categories A through E. E is a very high-speed aircraft, so the vast majority of civilian aircraft fall into the categories A through D. And thankfully, PANSOPs and TERPs, at least initially, start off with the same numbers. An aircraft with a final approach speed, that is, an approach speed over the runway numbers, of less than 91 knots, such as a Cessna 172, would be in category A, whereas a heavy transport aircraft, a heavy jetliner, such as a 747, may be in category D, 737 category C. So that's fairly straightforward initially. PANSOPs makes it a little bit more complicated by considering lots of other factors, lots of other speeds. So under TERPs, if I'm certified as a category B aircraft, that is, I normally fly my approach over the numbers around about 100 knots. If I have to circle to land at a speed of around 125 knots, I would have to use the TERPs C minima, because under TERPs the responsibility is on the pilot to choose an appropriate category for the speed of his operation. So certified under category B, flying speeds that would be appropriate for C, I have to use C. It's important to understand I cannot go the other way. I cannot ease into a lower category by flying slower. If you look at PANSOPs though, it has a range of speeds. So an aircraft that is circling at 100 knots, a category A aircraft that is circling at 100 knots, would still be category A under PANSOPs, but would be category B under circling. Now it's actually very difficult to find out which category the TBM 900 is actually certified in, but we can look at the speeds that the aircraft is able to fly. Final approach speed is 85 knots, so under TERPs for a straight-in approach we'd be category A, and we circle to land at 95 knots, so under TERPs, category B for circling. Under PANSOPs, our initial approach is slightly faster, maybe around about 120, 130 knots. Our final approach, about 1,000 feet, we're still doing 100 knots. We circle at 95 knots. The initial missed approach, that's around about 115 knots, and the final missed approach, flaps up, in icing conditions, is 135 knots. So under PANS we can only be in one category, whereas under TERPs we're certified for one category, we may have to use a higher category if the speed demands it. So though it seems like an easy concept initially, we've already added some complexity. For our TBM 900, let's say we're category A for a straight-in approach, Category B for circling approaches, and under PANSOPs, Category B across the board. Now, a straight-in approach can be up to 30 degrees difference between the instrument approach track and the runway alignment. So even with a 25 degree offset VOR approach, it's still straight in. But when you get to more than 30 degrees, it's a circling approach. So hopefully that's a little bit more straightforward now. Looking at the approach charts, here's 3 examples. We've got Sedona in Arizona, Taylor in Arizona, and Dundee, the subject of video 3, Dundee Airport in Scotland. So on Sedona, circling minima here, remember we're a Category B aircraft, so our minima 6,240 feet, 1.5 miles visibility. 6,240 feet on the altimeter is only 1,410 feet above the airfield itself. Sedona is a very high elevation airfield. At Taylor, it's a similar story. Minima for Category B circling, 6,380 feet, 1 mile visibility, but that's only 560 feet above the airfield. So although this number here is higher than this number here, you're actually far closer to the ground at Taylor than you would be at Sedona. And finally, Dundee, Category B, 750 feet. Dundee is almost at sea level, only 17 feet above mean sea level, so only 733 feet above the field elevation when you're circling to the south of the airfield. It's also important to understand that if we're flying a circling approach, we must use the circling minima. Despite the fact we're flying down a Category 1 ILS and then breaking off and circling to land, we cannot go down to 310 feet and then back up to 750. That's not allowed. Another point of interest, if you are using the UK official state charts, remember that this is an obstacle clearance altitude and not a directly usable minima. You've got to consider the system minima for the kind of approach you're using under the British system. Most commercial charts will publish a minima, just like the FAA charts do, but if you're using the CAA NATS charts, be aware you may have to change these figures here. But that's a story for another day. So circling minima, as I said, the whole point in TERPs and PANSOPs is to identify where the obstacles are that affect the flight and what area we have to consider those obstacles in. Thankfully for circling, it's fairly easy to visualize. We take every runway threshold. This is Belfast Aldergrove Airport. We draw a circle around every runway threshold and then consider an elastic band being stretched around these circles here such that you have a straight line between the tangent points on the circle. Everything within that area is considered. The highest obstacle is found, an appropriate margin is applied to it, and that becomes your circling minima. So that should hopefully be fairly straightforward. Here's Dundee Airport. You can see there's a radius drawn around runway 27, a radius drawn around runway 09, and we've filled in the little gaps here. The question is, what radius do we use? Now Dundee's in Scotland, so it's a PANSOPs airport. But we're going to use it as the example for TERPs and PANSOPs so we can see the same figures together. But remember, it's a state thing. You can't pick and choose whether you use TERPs or PANS. It's how the procedures are constructed. So under TERPs, with a field elevation or a low altitude airfield where the minima is less than 1,000 feet above mean sea level, these are the radiuses in nautical miles that we would use. Under PANSOPs, you can see they're a little bit larger. But remember, I said that PANSOPs includes an allowance for a higher circling speed, whereas under TERPs, that it would be the pilot's responsibility. So if you were an aircraft that under TERPs would be Category A straight in and Category B for circling, you'd probably be Category A under PANSOPs. So Category A PANSOPs gives you an equivalent level to TERPs B for circling. And the same story here, PANSOPs B, similar to TERPs C. We'll have a look at that again in a bit more detail. It's made more complicated by there being an older TERP system as well. About 10 years ago, the rulebook was changed ever so slightly Prior to that, the radius was a lot smaller. You can see a Category D aircraft would have 3.6 nautical miles of safe manoeuvring space, as opposed to 2.3 under the old system. And the old system didn't care about field elevation, so even if you're up at 10,000 feet above mean sea level, you would still have these figures here, whereas new TERPs, these figures change depending on the field elevation. So here's the charts again, the approach charts we looked at previously. Taylor is old TERPs, and Sedona is new TERPs, because old TERPs still exists. If the procedures haven't been redesigned or re-evaluated, then it's the old figures, the old radiuses they use. And the only way for the pilot to tell is this inverse C here on the new TERPs procedures. There's quite a bit of difference. These minima are within 100 feet to 140 feet of each other. But at Sedona, the pilot would be terrain safe out to 1.9 nautical miles from any of the thresholds, whereas at Taylor, only 1.5 nautical miles. Now, Sedona doesn't publish Category C circling minima, but if it did, they would need to assess obstacles out to 3 nautical miles, whereas at Taylor, it's only 1.7 nautical miles because it's an old TERPs procedure. There's quite a bit more manoeuvring space in 3 miles than there is in 1.7. So it would be very, very easy to come a little bit unstuck if you didn't understand that. Here's our TBM 900. We've said we're going to circle under TERPs, Category B, under PANSOPs, Category B, and the only reason this is highlighted, PANSOPs A is highlighted, is to demonstrate the TBM exhibits mostly Category A performance. It's the missed approach speeds that push it towards Category B. But you can see that even then, it's a fairly similar distance from the airfield. But I hope you can understand there's a bit more safety under the PANSOPs distances. Now consider a slightly heavier aircraft like a 767, maybe one of the earlier smaller 767-200s, or perhaps a 300. That's largely a Category C aircraft, Category C under PANSOPs, and Category C for a straight-in approach under TERPs. If you're circling in a 767, because of the slightly higher speed, you would have to use Category D figures under TERPs. Now put yourself in the position of a hypothetical 767 crew. You've been trained under PANSOPs. In every approach you've flown in the past 10 years, you've been a Category C aircraft, because that's all you are, and even when you circle under PANSOPs, you're Category C. And then you end up flying a circling approach to an airfield that's been constructed in accordance with TERPs procedures. And in the heat of the moment, you forget that it's your responsibility to check the speeds and to choose the appropriate minima. You're no longer Category C, you're Category D, and you forget that. And you make this mistake about 15 or 20 years ago, before new TERPs exists. And rather than having a nice safe 4.2 nautical miles to manoeuvre in, you have 1.7 nautical miles to manoeuvre in. And as we've decided 1.7 nautical miles is the radius that's safe for our TBM, you can understand that might be a bit dangerous in a 767. So let's have a look at that visually and see if we can get a better understanding how that affects us as a pilot. And one of the easiest ways to do this is to use Google Earth. Now, one of the very useful features of the Hotstart TBM 900 is its ability to output a flight data log. It records every single thing it does into the X-Plane output folder. And simply by removing a couple of header lines from that output file, you can import the file directly into Google Earth. When I was test flying the procedure, when I was designing the procedure, I must have flown the approach about 20 times working out what worked best. And then once I'd decided on that procedure, I went back and flew it over and over and over again until I got a trace that I thought best represented a perfect trace for this video. The procedure was taking 45 seconds from this turn here until the start of this turn here. So before this turn to before this turn, 45 seconds. the turn was 45 degrees, and then we used another 45 seconds from abeam the touchdown zone until the start of the base turn. Now I want you to remember, as I said before, that Dundee here is a PANSOPS airfield, but I'm going to overlay PANSOPS and TERPS information on this screen to compare the two. Let's look at PANSOPS first of all. And also remember that although what you're seeing here is a simple radius, this is around runway 27, the actual area would be stretched out to the west a little bit to include runway 09 as well. But the screen just gets a bit cluttered if we do that. So we were using PANSOPS B Minima, which is 2.66 nautical miles. You can see that's plenty of space for a TBM 900. Because remember that it actually demonstrates approach performance very similar to a Category A aircraft. It's only the missed approach that pushes it towards Category B. But using Category B Minima, there's plenty of space. PANSOPS C, this outer ring here, would be for the 767 example. Okay, now if I put TERPS on screen, you can see that the three radiuses for TERPS, A, B and C, are a little bit smaller. Let's zoom in here and we can see that PANSOPS B and TERPS C are virtually identical on the radius. And that's because PANSOPS B has that allowance for the higher circling speed, whereas under TERPS you would have to choose the next category up. So PANSOPS B allows circling at 135 knots and TERPS C being 121 and 140. It's the same story at the next ring in here. PANSOPS A allows circling at 100 knots, TERPS B 91 to 120. The TERPS A Minima, the very smallest radius here, would be a bit tight for a TBM 900. I have been able to do it. We can do circuits inside the bridge, inside this rail bridge here, but what we're looking for an instrument or finishing off an instrument flight is a simple, easy and safely repeatable procedure. Turning inside the bridge, especially in a simulator with a desktop monitor, is quite challenging. By extending the downwind leg a little bit, it gets a lot easier and a lot easier to repeat it time after time. So you can see the areas under TERPS are a lot smaller. That's why it's very important, if you're in a TERPS territory, to make sure that you're using the correct minima for the speeds that you're flying. As one final thing, let's consider that 767 again. The speeds on the 767 are probably about 70 or 80% faster than the TBM, so its initial turn would have it around about here, and then downwind would be somewhere around about here, comfortably within inside that PANSOPS C radius there. But think about my hypothetical 767 crew again, on that nasty afternoon where, in the heat of the moment, they chose the Category C Minima for circling under a TERPS airfield. And that Category C Minima only assessed this area here, whereas the Category C area they were expecting to be protected was this area here. With some of this elevation here being up to 450 feet above sea level, and all of this area here largely over water, you can understand that flying at an altitude that would be safe in this area, but actually out here, may not be a very safe thing to do. So I hope that explains the circling areas, the areas that are identified for obstacles. The key elements are, under TERPS, make sure you're selecting an appropriate category for the speed that you're flying, and make sure you understand what that protected area is. Understand what your procedure in your aircraft will deliver, and make sure that you're using a minima that stays within that radius. Thanks very much for listening. It's a complicated subject, so if you do have any questions or comments, please put them in the comment section below. I hope you tune in again for the next part of the flying video series. Thanks very much.